Okay, we have the function x to the fourth divided by 4 minus 4/3 x cubed minus 6x squared plus 3, and we hope to find the maximums and minimums, maxima and minima of f of x by using the derivative. So first we're going to find f prime x, the derivative. So x to the fourth over 4, when we do our power rule and multiply by 4, we're going to have 4 divided by 4, which is just going to be equal to 1. So we have 1 as our new coefficient, and then we do 4 minus 1 to get 3. Derivative of x to the fourth over 4 is just x cubed. Minus, when we multiply by 3, when we multiply 4/3 by 3, the 3's are just going to be equal to 1. They cancel to 1, so then we're just left with negative 4. So we have negative 4x squared minus 12x, and then the derivative of 3 is just 0. So carrying on, we have f prime x equals. Now remember, the goal is to set this equal to 0 and figure out what the x-intercepts of f prime are. So the first thing we're going to do is factor out a common factor, which they all have an x, so we're left with x squared minus 4x minus 12, and we're hoping this will be factorable. And of course it is, so we have x times x minus 6 times x plus 2. So that factors. So then we know that the derivative has x-intercepts at x equals negative 2 from this factor, and then 0 from this piece, just the x piece, and then 6. Those are our three x-intercepts, and that's where f of x is going to have a flat slope because the derivative is equal to 0. So then what we do is we make a table to analyze the derivative and figure out where f is increasing and decreasing. So we use our x-intercepts. So we're going to go from negative infinity until negative 2. And then we're going to go negative 2 to 0. And then we're going to go 0 to 6. And then 6 to infinity. We're talking about f prime x and f of x. Okay, so going back to the derivative from the very first form of it we have here, we see that it's x cubed, which means it's going to have an end behavior of down up. So that means that it needs to start negative since its end behavior is down on the negative side. So f prime starts negative, which means f of x starts by decreasing. And then we see that x plus 2, the factor causing this x-intercept, is a multiplicity of 1. So we're going to cross over to positive, and that means f prime is going to switch to increasing. And then at x equals 0, again, x is to the first power, multiplicity 1. We're going to cross again. Crosses negative and goes back down, so we're decreasing. And then it crosses positive once more, and now we're increasing. So anywhere that we go decreasing to increasing is a minimum. Anywhere going from increasing to decreasing is a maximum. So our minimums, we have a couple of them. We have one at x equals 6 and one at x equals negative 2. So we have x equals negative 2 and 6. And then our max happens at x equals 0 because that's where we go from increasing to decreasing. So we say max x equals 0. And that's it. So back in the Desmos activity, you can look at the slide that shows the graph of the derivative and the original function, and you can see where those maxes and mins occur.